And if the big black cat comes out, his name's Cookie, and that's my cat. He's really shy with people.
Yeah.
He doesn't move.
I doubt we'll see him today.
Yeah. He's not really used to new people.
Okay, it'll be just a second because we've got lots of people joining.
There's Marina, and there's another brown cat who has one eye. Her name is Misty. There's also a smaller cat.
Good morning. Good morning.
Fun fact.
Hi.
Okay. I'm going to wait for just a minute because there are only 4 of us here, and we'll let a couple others join. I'm going to attempt to record today so that we can send the links out. So since you guys are there at home, let me try and send you the notes really quick. Okay? Just a second.
China, this dude has a tail.
Yeah, I can do that.
Like right here.
Some of the spinal fluid goes back into a sack of skin on his back, so he has a tail. And
People think he's a goddess sent from the gods.
He thinks that they think he's a monkey god. Cat? No, they think he's like a monkey god because he's a human with a tail.
And so, yeah, let me show you a picture of him.
What on
sitting
earth
with
are
a
you
whole
talking
bunch
about?
of pillows
Guys.
in a bed and people all around him.
We have a lot of really, believe it or not, in fact, books.
And
Did you know a dog can hold 2 oranges right on their nose? That's so weird.
I have a bunch of weird picture books at home.
sorry, guys. Everybody. Okay.
River.
Do you want to hear something? Something pretty funny? So one time I was jumping up and down with socks to go to church because there's donuts and orange juice. And so my leg,
I've got the student.
both of them slipped under me and fell right hard on my chin. That blasted open. Zachary said, "That's a lot of blood." Not even wearing anything.
There we go. Okay, I just sent them to your parents' email, so you'll at least have the empty notes, and then hopefully I'll be able to send you the live links and you can go back through, okay?
And then Dad
Okay,
said, "Don't
all right.
let your mom see."
We are 5 minutes
Rushed out
in,
of the bathroom,
so I'm going to
screamed,
pull
and
out our
took me
stuff
right to
here.
the hospital.
Yeah,
And
okay.
then I did
Luli.
cry, then I broke my chin open again on the same day.
Luli, we'll have to stop, okay? All right, now you can go do your handwriting and your math downstairs, okay? And then when you're finished with that, I would like you to read some of the books that you can read, okay? Okay, guys, if you can print off, if you can't yet, that's okay. Just follow along with me. And then I will pass out, oh, of course, it's 3 pages. Exactly, you take 2, and then I have my stapler. That's kind of gross. No. My baking soda is leaking all over our school supplies.
Do you need the pack too?
Here, babe. I am so sad that this week's lesson got all messed up. This is my very most favorite unit in all of chemistry. I know. It's like, sad day. So for those of you, just take 3. Zach, take 1 sheet. Here. Honey, this is the packet. Did they print? Okay. I think that it should just be, is it one-sided for you guys?
Yeah.
Yep, there you go. It's one-sided. No stapler needed, so 1 for you and 1 for Noel.
Oh, thank you.
You're welcome. Okay. If you did your outline, if you're doing honors, and if you didn't do an outline, then make sure that you send me something saying that you watched the videos. Send me something from your parents, anything, because that's your homework grade. Without a homework grade, I can't give you the grade for the book portion, which is 1 high school credit. You'll need that. Yes.
Did you get the email that my mom sent you?
I haven't checked my emails this morning. I didn't see anything last night at 11 o'clock when I went to bed. So I'll check it afterwards.
I watched the videos and did the...
You're fine. This covers you.
Oh, okay.
You're way covered. And then I did not send out an email about the extra credit because we haven't announced the World Fair yet, and that might be weird. So if you want extra credit, the trifold boards with a subject that you really got into from our class that explains what's going on, anytime between now and the end of the semester is fine to turn those in. Okay? You don't have to do it. They are not required, but if you're missing some homework, please do a couple because it will kill your grade if you don't. All right. I have yours, Noelle, and I'm going to put that in my differentiated chem binder so that I can get that back to you. And check out my new readers so I can actually read. It's delightful. Okay. This week is acids and bases. No, not unless I'm reading. Acids and bases. And if you've never played with acids and bases before, you've never made like a baking soda and vinegar rocket or volcano, then think about when you get an upset stomach. If you eat too much sugar and then you get that burning like, oh, I should have never done that. Or too much orange juice. Oh, I shouldn't have done that. And all of that burny feeling. And then maybe your mom will give you a Tums or you'll drink like some baking soda water and then you'll burp a bunch. But it'll settle down. Even if you just drink plain water, you have to drink a lot of it, but will settle down. It's because there are acids and bases. And they're sort of like the yin and the yang. Do you guys mind if I turn off this big light? Are you still able to see? Probably not. You probably can't see very well. We'll turn it back
So that's a beautiful.
on. Okay.
She has
I'll turn this one off.
had 2 sisters.
There. Can you guys see me okay still, or is that too dark? You're good? You're good? Okay, let's try that. So acids and bases are like yin and yang. They are opposites. And this time they do still attract, but depending on how opposite they are, the bigger bang when they come together. So like if we take hydrochloric acid and lye soap, we're going to have a big problem because that hydrochloric acid is like the strongest acid that we have, and lye is like the strongest base. And so when they come together, it's strong plus strong, and it's World War III, okay? But if we take a medium acid and a medium base, vinegar and baking soda, we have a pretty explosive, bubbly, woo, reaction. But then eventually it all kind of evens out, right? It stops. So if we've ever done vinegar and baking soda together, it eventually will stop. And that's because they will neutralize. Okay, I just wanted to talk to you a little bit about the acids and bases before we get into the lecture notes because I wanted you to see them. Okay, now I have an activity. It's going to be, I'm so sad that there are not 12 of you here. That's okay. 3 of us are going to lick litmus paper, and then I'll show you mine, okay? So I've got to find my litmus paper, and I think it's in with all my chemicals, so give me just a moment. Yeah, here we go. And Aquila, was it you who's missing soap? Okay, don't let me forget. I got it. It's here for you. Okay.
I told her that I climbed up beds in her room. I taught her how to climb up.
Wow.
So
There it is. Okay. So this is pH paper. And I'm going to come over here to you. There is, yeah. This is the scale of the colors that the acids will turn the paper, okay? And we pass out some paper here. I cannot touch the hand sanitizer
Yet.
because it will affect this, so. Okay. Oh, I'm sorry. Okay. So, note the color of the litmus paper. This is for you guys. You can each actually have one because I have another scale over here. So this is the color of the litmus paper, and I did a boo-boo. I had coffee, and then I just ate something too sugary. So I probably shouldn't have done that. I'm gonna take a sip of water.
Oh, she's got a little spot on her back.
Yeah. She also has a mustache over here.
Okay, I'm gonna swallow that water, and then I'm gonna gather up some spit in my mouth. Okay, gather spit, y'all. It's gonna get grosser than this. We're gonna spit into cabbage juice later, and if you're not comfortable doing that, I will do it for you. I will spit for you. Okay, once you have some on the end of your tongue, just touch the litmus paper to it, and then it'll begin to change colors. And in a few seconds, it will turn the color that of the acid in your mouth. And then, whoa, then gauge it to your color chart. So here's a, this is really hard to do. 4, I think it's really like a 5. Let's see.
This would be like,
5, maybe a 6.
I feel like that's a 5. Oh, you guys are 12. I don't
Let's see. I'm sorry. So you think that's a 5? I think it's probably a 5. Okay. Now I'm gonna take this and throw it out.
Yes.
Zachary, pitch it out.
Oh.
Sorry. Super sanitary. Good job. Yes. Now you know what the inside of a trash can looks like, Noelle. How do you feel about that?
Honored. I feel honored.
Good. Okay. Now we're going to taste some things. Now everybody here has had soda, right?
Not today.
Not today, Zach says. Okay. Well, I'm going to give you a little bit of my favorite wine. This is red wine vinegar. And so I am going to put it in a Dixie cup. I've got little Dixie cups here, and I'm not going to give everybody very much because who wants to drink vinegar first thing in the morning?
Me.
I enjoy vinegar.
You probably do, you weirdos.
You have put vinegar in your food.
Yeah, I put vinegar in my food.
So I taught folks like how to form butter.
Zach. Okay, so I've got a little vinegar here. It's just red wine vinegar that I bought at the store. And I'm going to test mine with a pH strip. Let these guys taste it. I'm sorry, he's really excited about that ball. Okay. And just take a little taste, and then not every acid is safe to drink, but this is an acid that is safe to taste. So we're going to taste it. And How does it taste?
I'm not brave enough.
You're not brave enough. You can smell it and know it tastes how?
Bitter.
Bitter and kind of maybe like sour. Woo! Pucker power, right?
I had vinegar before. It's
Vinegar.
delicious.
You can have some of mine, okay? Vinegar generally has a sour taste, okay? And we can smell it right away. I mean acid. Acid has a sour taste. We'll try another chemical reaction in our mouth today with citric acid that is actually homemade Pop Rocks, okay?
I knew it.
So I'll show you that and I'll give you guys the recipe so you can try it at home if you have the ingredients, okay? But now I'm going to take my litmus paper, and Noelle, if you'll pass a piece of litmus paper to Zach, we're going to test the acidity of this, which is clearly more. That's okay, I'll give you some more. We'll test the acidity of our vinegar. There's probably a dribble in there. All you need is a dribble. And see the difference between our saliva and this vinegar. Hey.
Maybe I think about a 3.
Okay. So we'll test the acidity. I'm going to match up the colors.
It's about a 3.
What do you guys think? Let's see if I do this right. What color or what number?
2 or 3. Depends on how. I can't tell if the print on this thing.
What
is
color?
actually-
3? What do you think, Annie?
3.
I can't really read the numbers. I know it looks like red, but I can't really read the numbers.
Yeah, and they're
Oh.
upside down and backwards.
Oh wait, no.
It
It's
looks
a
kind
4.
of like a 2, I think.
Maybe like a 2. Yeah, close to a 2,
Yeah, probably that.
not quite a 4.
Mine says 4.
Maybe a 4, maybe a 3. Yeah, somewhere in that range, right? Okay, so this is a pH indicator. And that's going to give us the strength of our acids. So, we'll come back to that. All right? Libby, you can drink my vinegar.
Yum.
And you guys will just collect your cups afterwards, okay? Do you want to try any more acids right now? Okay,
As long as it's not vinegar.
as long as it's not vinegar. Okay. All right, the next one we'll try then is a piece of citrus, which is right here.
That
Yum.
shouldn't be bad.
Yummy.
That's that. I enjoy most all acids I've learned.
Okay, so I have a little orange here. Just gonna cut it into, I only need like 3 or 4 pieces so we can taste it. And surely you've all had an orange before. You're pretty excited, aren't you? Get the dishes out.
I think I got vinegar in my nose.
Oh.
I love the smell of vinegar. How do you guys not?
It is horrible. I hate smelling. That might be one of the worst smells I've ever smelled.
Vinegar? I'm so sorry.
Oh no, it's not you. Just
Don't eat it yet. Take your litmus paper and touch it to your piece of citrus. And we're gonna test the acidity of your citrus and compare it
With the same thing.
We're just gonna touch it to the citrus, get it wet with the orange juice,
Snack.
and then you can eat it.
I agree.
This is amazing snacks.
I agree on 6.
Here.
Mama,
yeah, that's about right.
Mama.
Just a second.
Mm.
Okay, let's have a look. I think that it's probably ready.
Probably 4.
Yeah. Yeah, definitely a 4. Or Well, it's not 6 anymore. It's not 5. Yeah, it's 4. What do you think?
Probably like 5. Like 2 yellow.
Let's see. Yeah, I'm thinking it's so hard to do here.
I'm thinking
5 maybe.
Yeah, 5.
Maybe even a 4.
Yeah.
Yeah, 5 or a 4. Okay. So what was my saliva? I forgot.
It was like orange.
Like a 4 or 5. All right. And then the orange was like a 4 or 5. And then we decided that the vinegar was, maybe I turn it this way. The vinegar was more like a, maybe 4 or 5,
Liquid?
right? Okay. So keep those in mind. We'll pitch out the rinds and that. You guys can keep your plates for right now. Liv, you can't drink. No more vinegar. That's not good. Okay. And now that we've tasted some acids, let's go ahead and get into our notes. Because now it's 9:23. Okay. Okay. So, when it comes to acids and bases, lots of people have lots of ideas about what acids are and how to categorize them. They kind of disagree on the definitions. So I'm going to read a little piece to you out of our book, just the first 2 paragraphs, and give you an idea. Acids and bases that we've used in our chemistry so far are usually solutions of relatively simple inorganic substances like hydrochloric acid, sulfuric acid. We've done boric acid, sodium hydroxide, and things like that. But acids and bases are important even when we're not in the laboratory. They are ubiquitous, including the foods that we eat. Ubiquitous. Do you know what that means? Means everywhere. They're all encompassing. Everything is involved in it. And that's what's that? You don't have to spell it, but if you want to, you can. Just say everywhere. ubiquitous. Ubiquitous. Okay. The characteristic flavor of grapes in this picture that they have over here is largely due to tartaric acid. Do you know what tartaric acid is? How many of you have ever used cream of tartar when you're making meringue, cookies, or anything like that? It comes from grapes, tartaric acid. They're little crystals. If you make homemade grape juice, you know those crystals we get in our grape juice?
Yeah.
That's tartaric acid settling out of the it's causing precipitate. Okay. And also malic acid. The 2 are closely related. They're only different by 1 oxygen atom. And are organic acids that are found in biological systems. The fermentation of the sugars in the grapes ultimately forms vinegar. Before it gets to vinegar, it starts as wine, and then when wine sours, it goes to vinegar, okay? That's the tangy, sour flavor that we get with vinegar that we smelled and that we tasted this morning is due to acetic acid. Acetic acid is CH3COOH. It's a substance that we'll talk about again later, but the sour taste of oranges is ascorbic acid or vitamin C. So we tasted acetic acid today and we tasted ascorbic acid today. And then later on we'll taste citric acid when we get to our Pop Rocks, okay? Mostly when you get bored with taking notes, then I'll change it up and have you taste Pop Rocks, okay? All right. Let me make sure here. Acids and bases are among the most important substances in chemistry, and they affect our daily lives in innumerable ways. Not only are they present in our foods, but acids and bases are crucial components of living systems, like the amino acids that are used to synthesize proteins and the nucleic acids that code genetic information. Both citric and malic acids are among several acids involved in the Krebs cycle, called the citric acid cycle, that is used to generate energy in aerobic organisms. So that was a whole lot of mumbo jumbo just to help you understand that in order for you to be alive, you need vitamin C. In order for you to make energy from the food that you eat, you need citric acid or vitamin C, okay? The application of acid-base chemistry also has critical roles in shaping modern society, like the human-driven activities of industrial manufacturing, the creation of advanced pharmaceuticals, that's medicine, and many aspects of the environment. Another thing that we don't think about as often are soaps and our chemicals that we use in our house. Acids and bases. Ammonia, general household cleaner. It's very basic. We'll find out maybe. We're going to do an experiment a little bit. Okay. Now that you know a little bit more about acids and bases, you might understand why it's one of my favorites in chemistry, because it really is everywhere. It really is everything. Your soap, your water, your digestion, our life, all of it depends on acids and bases, and children. And actually the creation of children. In order for children to have their genetic information coded into DNA, you need vitamin C. Everybody eat an orange a day. Okay?
But we already did.
Yeah, you already did. Okay, here we go. Into the notes. Number 1, acids have a sour taste. They are very reactive with metal, and they also cause some dyes to change color. If you've ever made homemade jam or jelly, and then you have to put lemon juice in to increase the acidity of the food, yes.
What should I write for that?
Number 1, acids have a sour taste, comma, are reactive with metal, and cause some dyes to change color. We're going to play with that today. I have some dye that I made, some homemade dye. So I don't know if you can see that it's really, really, really purple. Made some homemade dye from purple cabbage, and we're going to play with that today. All right, number 2, bases have a bitter taste. Oh, I didn't have you taste base. Now you have to taste it. So I'm just going to sprinkle a little bit of a base on a spoon for you. And the base that I have for you is, baking soda. Baking soda is a base, okay? Which is why if you ever have a coffee pot that's all kind of like coffee stained and it doesn't want to come clean with just washing it in dishwater, a little baking soda will cause a reaction with the acid in the coffee, and it'll come right up off the pot, and it'll be so clean. So here is a little taste. All I'm really doing is just scooping a teensy amount onto a spoon for you to taste, just a teeny bit. That's more than a
Soda wasn't edible.
What's that?
Baking soda wasn't edible.
You brush your teeth with it and you put it in muffins. It's a muffin.
Oh.
It's quick bread. You can just lick it or not. You don't have to. You do not have to. Did you get a spoon? Olivia is enjoying being a part of our high school class today. She's like, this is way better than... Okay.
Just try it a little bit.
You don't have to. Hey, don't make her.
That's really all you need.
Okay, so in your toothpaste, if you have all natural toothpaste or whatever, if you lick it, if you taste it, it tastes kind of, how does it taste?
Salty.
Salty.
That's what I thought,
Yeah. What else?
Bland.
Yummy.
A little bland. It's salty, and it should be
Yummy.
a little bitter and slippery. If you've ever gotten baking soda on your hands and then go to rinse it off, it's very slick. Or bleach, if you've ever accidentally, like I'm doing laundry and I get a little bleach on my hand and I have to rinse it off, it doesn't want to quite come off. It takes forever to get off your hands because it's slippery. Okay? So number 2 is bases have a bitter taste. Please don't ever lick bleach. Not all bases are safe to eat. Don't do that. Okay?
Cookie.
Similarly with acids, not all acids are safe to eat, so don't do that, okay? They are also slippery, and they also cause some dyes to change color. Write down those answers for number 2. Bases have a bitter taste, are slippery, and also cause some dyes to change color. Okay? Number 3, this is how a base reacts with an acid. A base lowers, that's number 3, lowers the amount of acid. They are like neutralizing opposites. Okay? Here's an example. Remember how we opposites attract, and you know. I'm going to make you learn that Paula Abdul song before you leave my chemistry class. It's the answer to most everything in the world. Ready? Opposites attract, and you know. Right? It's the same with acids and bases. Okay? I am outgoing, and I love to be around people, and I like to talk, and I like all those things. But my husband, he'd rather be alone, rather be quiet, not go out anywhere, not interact with people. He's very opposite of me. It's probably why he loves me and I love him, because we're good for each other. Together, we make a good balance, right? Acids plus bases together balance, okay? If we put an acid in with a base and mix it, once they're done fizzing and bubbling and doing their thing, they will both be more neutral, okay? They will both be more neutral. All right, number 4, we're going to define an acid, okay?
Good boy.
This is one definition of an acid. Now, don't freak out on me. We're gonna finish building the definition as we go, okay? But an acid is, write this down. Zachary, push him down.
Cookie.
A substance that when dissolved in water increases the concentration of, hang with me, hydronium ions. Don't freak out. Hydronium ions. What is that? What is that?
Can you say that one more time? Sorry,
I'm
I didn't
happy
get
to.
it.
Yeah,
Thank you.
no problem. Acids are a substance that, when dissolved in water, increase the concentration of hydronium ions. Hydronium is, Libby, would you run downstairs, get Mommy a dry erase board and a marker?
Yeah.
Okay. Hydronium is labeled H, lower 3, O. Okay, I'm going to get Olivia's getting a dry erase board for me so that I can show this to you, okay? An acid dissolved in water increases hydronium. Hydronium is H3O. H3O? I know what H2O is, right? Thank you, honey. We've got a dry erase board here that's a little worse for its wear. But
Maybe the other side.
what?
Is the other side better?
No. H3. Oh, is that right? No. Guys, I'm really sorry. I think all of is this regular for you or is it backwards? We good? Okay. H3O. What do you notice? If I change the 3 and I lose 1 hydrogen, I get H2O. Where does that H go? Hanging out over here on the side. Remember how the alkali metals and have 1 extra proton and they're desperate to just throw that proton at anybody who will take it.
And then
Right?
the other proton.
You have to be quiet. And then the halogens are just howling. They're so desperate. They'll steal an electron. Oh gosh, I said electron, didn't I? Or proton. I meant electron, right? Remember that? How the alkali metals are super reactive because, like hydrogen, they have 1 electron that it's just freaking them out. They got to get rid of that one electron or find another one to pair up with, right?
And there's the
Okay.
halogens that are halogens.
Acids are like that. They are desperate to
get rid of.
give up one of those hydrogens. Okay. And when they give up that hydrogen, they make a water. Okay. So hydronium. Oh, I did too much. So hydronium is H3O. Keep that in mind, will you? Now we'll define a base. A base is a substance that, when dissolved in water, you should be writing this down. That when dissolved in water, it increases the concentration of
CH2.
hydroxide. What is hydroxide? Nope.
Is it ionized?
Nope, hold on. Take a look at acid. H3O, right? Hydronium. Let's change it. HO. Ho, ho, ho is base. Except they write it like that. Why do they have to make it so complicated? Just keep it the same. It's fine. Okay. OH is hydroxide. Okay. Hydroxide. Look, it's also just almost like, if I change it back around to this, what is it really close to? It's also really close to H2O. Look, it's only one hydrogen away from being H2O. Hold on. You mean to tell me that H3O is desperate to get rid of an H, right? Mm-hmm. And when it gets rid of an H, it becomes H2O, right? Acids want to be more like a base. A base wants to be more like an acid. One gets rid of a hydrogen, and look, a base, which is HO, takes that hydrogen and it also becomes H2O. Everything in the universe wants to be balanced. Everything in the universe wants to be whole. Isn't that cool? Okay. So does everybody have number 3, number 4, and number 5? Okay. I am going to read to you about number 6, proton transfer reactions. Okay? 673. Okay. Proton transfer reactions. In a reaction that occurs when hydrochloric acid dissolves in water, the hydrochloric acid molecule transfers a hydrogen ion. Ooh, remember how I just wrote that down for you on our board? Remember, I had H. Yes, Annie. Yes, Annie.
Is it okay if I just go to the bathroom real quick? Thank you.
I'm so sorry. I did not hear you. That's okay. I didn't hear you.
Is it okay if I go to the bathroom?
Of course. Get up and go, honey. Go.
Is it okay if I... Oh.
Go
Okay,
ahead.
thank you.
No problem. Go ahead. I'll send you the links. Okay. So, where did we go? Okay, so they transfer a hydrogen ion, hereby known as a proton. Why is it a proton? Why would it be a proton? Because hydrogen only has one proton, which means it also only has one electron. Good job, Olivia. Okay, so remember how we were were talking about it was desperate to throw the alkali metals were desperate to throw that electron. Well, acids are desperate to throw that proton of hydrogen, that hydrogen ion, and it's ionized because it has a -1 charge. Okay? Okay. I lost my spot again. I'm so sorry. No, it has a +1 because it's got the 1 electron hanging out it wants to get rid of. Okay, so we're going to represent it by drawing an acid and a base. I'm going to draw the molecules for you. We have an acid. Okay. We have an acid, which is it's got a hydrogen molecule here. Okay, right there. And then we have a base. I'm just going to label it B. Okay? And this base looks like this. Okay? When we have a chemical reaction, too big. Sorry guys, I didn't plan my space well. Okay, now we're planning this better. Remember that this is our acid, this is our base, okay? And when they come together, the acid ditches its hydrogen molecule and the base picks it up. So now we have this there. Okay, so we have the acid plus the base ditches, the acid ditches its hydrogen and the base picks it up. That's all proton reaction is. Can you draw this picture on the line for number 6? Okay, and label them. You'll label it acid and base. Okay, and then you'll get the product. You can just leave the product unlabeled. You see that okay?
Yes.
There we go. Okay, Liv, how are you liking this? You so happy? You're my science buddy, aren't you? Yes. Okay. Once you have that down, and now that we know about proton transfer reactions, we can add to the definition of an acid that, you ready? Okay. We can add to the definition of an acid that an acid is a substance that donates a proton to another substance. Okay, got that? Now, if we know that an acid donates a proton, what can we also add to the definition of a base? Oh, you're killing me. Livy, if an acid donates a proton, what does the base do? It takes it. Oh, yeah. This kid's passing high school chemistry. Oh, yeah. And she's 6. It's amazing. If only she could just read all the words, right? Just kidding. We can add to the definition of a base that a base is a substance that accepts a proton. Proton. It matters in the case of acids and bases. Zach, that was such a good question. It matters in the case of acids and bases that the entire atom is moved. Okay? The entire atom, which includes the proton. So that's why we say it's a proton transfer. Okay? Good job. Does everybody have that down? Okay. These are my favorites. Every rule is meant to be broken. There are exceptions. There are exceptions to every rule, and chemistry is no different. Some substances act as an acid in one reaction and a base in another. Okay? Water is an example. Okay? I just caused a chemical reaction to happen in my tummy. Let's see. Okay, I think the water's there now. I feel that cold water in my belly. In my stomach, I have what? What kind of acid is in my stomach? Hydrochloric acid. In my stomach, I have hydrochloric acid, and I just put water in. We didn't test it. We didn't test it. I got to dip a pH strip in my water. You know I have to, right? Okay. Oh, I can't lick my fingers and get it. Then I'll have spit on it. I got it, babe. Thanks. Okay. I'm going to dip my litmus paper into water, and we'll see what color it turns my litmus paper.
It's kind of darkish.
Looks like maybe from this angle.
7, 8, 6, somewhere in there. 6, maybe a 6 or a 7 or an 8. Okay, I'll come show you guys. Okay, this is just water, so we're looking at a pH of maybe an 8, not quite a 7, maybe an 8. Okay, but this is this paper, so maybe 6, 7. Somewhere in there. 6, 7, 8, right? We can agree to that? I got really close to you. Put that right there. Okay? That's because water's neutral. Okay? And it's reacting in my stomach with the hydrochloric acid, and it's actually neutralizing that acid. And by neutralizing that acid, the water is acting like a base. Okay? How many of you have ever, do you know what Alka-Seltzer is? We're a bunch of crunchy homeschool folks, so I don't know if you do. Alka-Seltzer, plop, plop, fizz, fizz. Oh, what a relief it is. That used to be the commercial for Alka-Seltzer. You drop a tablet of Alka-Seltzer into water and it'll fizz, and then you drink that down. Okay? And that's because, let's see, is it Alka-Seltzer? Base? Oh. Let's try it again. If I put some baking soda into my water and stir it up, sit down, then the water is going to act like an acid to increase the acidity and help neutralize the baking soda. Okay? Got a little off track there with that whole pop, pop, fizz, fizz. Okay, so these back and forth substances that can act as an acid and can act as a base, they have a name, and they're amphiporic. What? Let me help you. I have a dry erase board now. I feel like I'm unstoppable as a teacher. Okay, amphiporic. Here we go. Are you okay?
Yeah.
The answer for
Here you go. Amphiporic. 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 Say it with me, class. 1, 2, 3. Amphiporic. That's a weird word, but I promise if you use that word to describe anything that can go back and forth, you will impress people. Okay? Now you've learned some vocabulary for today. You can say water is amphiporic because it could act like an acid or act like a base. Okay?
Is that why those pH strips have a little bit of red here?
Yeah, I probably touched it with something on my hand. I cut those oranges and things. I probably had some acid on my hand. Plus, I've got dry erase on my hands now, too.
But that was
Okay.
before you had the dry erase thing.
Ready? Okay. The neutralization of an acid and a base produces, we saw already that hydronium plus hydroxide equals water, right? But there's more to an acid and more to a base than just hydronium and hydroxide. So we know that it will produce water and it will also produce a salt, okay? So when we add an acid to a base, the end result, the product, is salt and water. Okay, write that down. That's number 10.
Oh, wow.
And then I think I have on there, think of H3OCl, hydrochloric acid solution, plus sodium hydroxide. And that equals literally salt water. Okay. We do not have time for conjugate acids and conjugate bases. So let's just skim over that really quick. I knew I would do that, so I said if I have time. Conjugate acids and conjugate bases. If I have hydrochloric acid and I remove one of the hydrogen atoms, I'm going to get its conjugate base. So a strong acid will make a weak base, will turn into a weak base, and a weak acid will turn into a strong base. Okay? That's the whole idea of the whole thing. You don't have to write any of that down. It's not going to be on the test. I'm going to mark that right now. Done. Now, we've defined an acid and a base a couple of times already. I need to do it one more time. Okay? We have done mostly the Bronsted-Lowry definition of acids and bases. Mostly. But most of the time, people refer to Lewis acid and base definitions. Okay? So an acid is defined by Lewis as an electron pair acceptor, and B, a Lewis base definition is electron pair receptor. Okay? Yes. Absolutely. 12A, an acid is an electron pair acceptor. And B, a base is an electron pair receptor. So acceptor for acid with an A, receptor for base with an R. Okay? You guys have that out here in the peanut gallery?
Yes.
Okay, good.
I'm sorry, could you say it one more time?
Absolutely. 12A,
How do you spell receptor?
receptor, R-E-C-E-P-T-O-R.
No, thanks.
No trouble.
12
So
feet.
that's 12B, receptor, electron pair receptor. And then 12A is electron pair acceptor. Okay? So number 13, Lewis acid base definitions emphasize what instead of proton? Electron pair. Okay? So number 13, the first blank, Lewis acid base definitions emphasize the shared electron pair rather than the proton. Okay? See? Electrons really do rule the universe.
Because in the electrons there is in the atoms there's electrons.
Okay. You ready to do a quick break? Okay. I happen to have citric acid Pop Rocks that I pre-made for us. This is homemade Pop Rocks. It's a chemical reaction that you can taste. In this bag, I have 6 teaspoons of sugar, 2 teaspoons of baking soda, and 1 teaspoon of citric acid. Citric acid can be found in the canning aisle of your grocery store, or you can order it online if you want to make like bath bombs and stuff like that. So I'm going to get a couple more spoons, and I'll let you taste this, and then I'm going to stick my face in the camera, let you guys see it on my tongue. So this will be the 3rd acid that we taste today. You do not have to if you don't want to. Okay. Oh, you want to?
This one is actually really good.
Just don't get too much of it at a time.
Yeah, just a teensy taste. You want to try some, Sissy?
I already had some before, so I want more. 'Cause it's so good.
It's gonna have a
Okay.
strong baking soda flavor with the acid. How's it taste, kid? Yeah, you looked really pained there for a second.
The sugar helps it, okay? That's a lot, so maybe half of that, okay? Okay. And I'm really going to do it up for you guys so that you can see it.
No, we're...
In the spoon, it's a dry substance and it's not reacting chemically at all, okay? But when I put it in my mouth, it's going to react with my saliva.
And it's very salty. Salty and good. Try it. Did you?
I gotta get taste out of my mouth.
Try some of it.
Oh, that was really fun.
Okay.
It's slippery afterward. Yeah. I mean, no, that's to be expected, but it's still weird to feel that.
Kind of a lot.
No, it's not. But it's
Well,
like
I think I got a lot of baking soda. So, if you want a glass of water,
Oh, no.
Goody.
if you want a glass of water, I have some more Dixie cups. You guys want some?
You can have mine. I'll take off the part that I like.
No, Olivia, you don't need any more. Have a seat, my dear. Do you need water, guys?
Yes, please.
Not me.
Oh,
Not me. None for me.
Okay. It was kind of intense. But now you've had citric acid. You got to feel baking soda react with the citric acid. And then the sugar was there purely.
Whoa, nice.
The sugar was there purely, so it didn't taste so bad. Okay? All right. Now, we have tasted acetic acid, citric acid, and what was the other one that we tasted?
Hey, Mama.
Acetic.
Look at
Citric
this. It's
and,
amazing. A whole bunch of colors.
I saw it. Yeah, it's having lots of reactions. And the orange one, it was, I'll think of it. Anyway. All right, so now let's talk about this pH scale. We felt those protons jumping around in our mouth, and you guys can feel that
Come on.
when you guys try it at home, or else maybe next week I'll bring some, okay?
Do it.
Ready? Ready? Ready. Okay. So the pH scale is what we've been looking at with our litmus paper. Okay, this color scale, camera keeps tipping, is not important, but the number scale is. The numbers on that are actually the scale that represents how acidic or alkali an acid or base is. So, number 1, the pH scale is used to express the acidity or alkalinity of an acid or a base. I'll say it again. The pH scale is used to express the acidity or alkalinity of an acid or a base. But what does pH stand for? And I'm going to get my dry erase board again because they write pH really weird. And this is another one of those chemists being weird moments. pH is written with a lowercase letter first and then a capital letter. It's super weird. Why would they do that? It's power or potential of hydrogen. So why do we capitalize hydrogen like this? Because the capital H is the elemental symbol for hydrogen. Oh, at least they do have a reason for being weird, right? Okay, power or potential, and there's argument about what this P means, but basically is how much H is there in this, pH. So if we have a really strong acid, then we will have a really, ready? Really low pH. What in the world? That doesn't make any sense. Do you remember that we had, which one of our things that we dipped our litmus paper, which one was almost red? It was like a 1 or a 2. Do you remember? Was it the orange? Was it the vinegar? It was the vinegar, right? Wasn't my spit. I think it was the vinegar. So vinegar had the lowest pH, which means it was the strongest acid. Okay? So that's kind of backwards. So let me say it again, because this is actually number, I have 2 number 2s. 2 number 1s and 2 number 2s. Will you correct that for me in your notes? It should be number 1, the pH scale is used to express the acidity or alkalinity of a base. Number 2 should be pH stands for power or potential of hydrogen. And then the next one should be number 3. Neutral solutions have a pH of 7. So if my water had come from the Berkey that I have over here and there was nothing in it, this water would have a perfect pH of 7. But I actually got tap water, and noting that it comes with that I tested it and it was an 8, that means that my filter on my cold water needs changed because it wasn't perfectly alkali. It wasn't perfectly neutral. I'll have to change my filter on my sink.
Now we're going to have to test our Berkey water.
Oh my gosh, we are. We're going to have to test our Berkey water. Ooh, science in real life. Yes. Okay, so neutral solutions are 7, and that's number 3. And then the next one, acid solutions have a pH below 7, and that should be number 4. Silly Mrs. Kerner. I don't let him autocorrect, and so sometimes I mess up the numbers. On my auto format. Okay, and then number 5, which is labeled on your paper as
3.
Number 3, is basic solutions have a pH of above 7. All right. Goofy. Okay.
What was number 4 again? Sorry.
No problem. It's below 7.
Thank you.
No problem. Okay, so we could write that acidic, cross off, draw the chart calculating pH on 681. All it wants you to do is write acidic, all I wanted you to do, acidic, neutral, and then basic. Basically, less than 7, 7, greater than 7. That's it, okay? And you already have that written. And these are, let me make this more clear. Those are 7s, okay? You don't have to write that down if you don't want to. Then we're going to draw the common acids and bases on the pH chart. I do want you to do that because that's really what our experiment today is going to be all about. Okay? So we have numbers 14 down to 0. Okay? And they go right down the middle.